Here are some additional power rule example problems. In example 5, f prime of x is equal to, now if you think about the square root of x as x to the 1/2 power, we can go ahead and multiply. 1 times a half would be half x, 1/2 minus 1, to the negative 1/2 power. In AP land, they would most likely change that to 1 over 2 square root of x. This is a derivative that is so popular with AP that we should memorize that answer to save time. In example 6, dy dx is equal to, now here we have the same root function again, so we can do 2 times 1 over 2 root x. 2's can cross out, and we're ending up with 1 over root x. In my next example, f prime of x is equal to, again we have the square root function, so 4 times 1 over 2 root x. 4 and the 2 can cross cancel, minus, and now we've got 6 times 1/3 is 2x to the negative 2/3 power. In example 8, dy dx is equal to, let's think about this as x to the negative 2 power. If we stick a 1 out in front, we can multiply 1 times negative 2, so we get negative 2x to the negative 3, and we could bring that exponent down and make it positive. In example 9, f prime of x is equal to, let's think about this as x to the negative 4 power. So we would have negative 4x to the negative 5. Let's think of this as x to the negative 2. So then we have positive 8x to the negative 3, and the derivative of a constant is, of course, 0. Alternate answer in AP land, they would most likely go ahead and bring this back down and bring that second term back down. In example 10, dy dx is equal to, 5 times 4 would be 20x cubed. There's our root function again, so 1 over 2 root x. And then here we can go negative 2/3 x to the negative 1/3. In example 11, I would break this up before we start. I would go y is equal to, and I would turn it into 1/2 x to the 4th plus 3/2 x squared. If we split up that fraction, we can then do each term one term at a time. Dy dx is equal to 2x cubed, 1/2 of 4 of course is 2, and then when we multiply here, 2's cross out and we would get 3x. Same idea on this one. Let's split it up before we start. Our first one would end up being just x to the 5th power. Our second term would be negative 2x to the 4th power. So f prime of x is equal to 5x to the 4th minus 8x cubed. In these examples, now we're doing not only the derivative, but we're going to plug in a number after we take the derivative. So f prime of 1 means take the derivative and plug in a 1. So our derivative, f prime of x, would be equal to 12x squared minus 6x. We're now going to plug in a 1 to that derivative. So 12, 1 squared minus 6 times 1 would be 12 minus 6, which is 6. Example 14, we have a slightly different notation, still means the same thing. Take the derivative first, then plug in a value. So dy dx is equal to 12x cubed minus 12x. We're going to plug in a 1, so dy dx at x is 1 would be 12 times 1 cubed minus 12 times 1, which is 0. In my next example, again, slightly different notation, still means take the derivative, plug in a value. So y prime would be 12x squared minus 6. I then want y prime of 0, which would be 12 times 0 squared minus 6, which is negative 6. Now we're getting into what the derivative actually means, and the derivative helps you to find the slope of the line tangent to a curve. So if I want to find the slope of the line tangent to the curve, I'm going to first take the derivative. Dy dx is 20x to the fourth minus 12x, and then I'm going to plug in a 1. So dy dx at x is 1 would be 20 1 to the fourth power minus 12 times 1, 20 minus 12 being 8, and that would be my slope at x is 1. Going again with that, slightly different, we again have f prime of x. Here's our root function again, 1 over 2 root x. Then we can go minus 6x to the negative 4, because 2 times negative 3 is negative 6. I would bring that to the bottom of a fraction, because when I plug in, that would make things easier for me. So 1 over 2 root x minus 6 over x to the fourth power. Now when I do f prime of 1, I get 1 over 2 root 1 minus 6 over 1 to the fourth power. That looks like 1/2 minus 6, which is negative 5 and 1/2. We could also think of that as negative 11 halves. And that's it.